Microgrid system mainly includes microgrid central controller, distributed grid connected device, simulated photovoltaic DC source, photovoltaic inverter, power conversion system, battery, edge computing device, etc. The edge computing device connects the microgrid central controller through a network port to collect real-time data using the standard 104 protocol and remotely monitor the system. The edge computing device provides data collection, security encryption, authentication control, privacy protection, and malicious attack defense for security protection. The microgrid edge computing system consists of grid security, grid data, and grid business. Part 1. Grid security. Encryption and authentication are the essential security safeguards on the edge side. Illegal parties may intercept data packets during data transmission. The system employs different encryption algorithms to provide data protection with varying strengths of security. Access authentication. Illegal parties may inject the malicious program to disguise as the legal packet to launch an attack. Without authentication, both illegal and legal packets can access the system. With authentication, malicious illegal packets are flagged and not pass. Authenticated legal data packets are displayed in plaintext and ciphertext and show the corresponding authentication results. Real-time sensitive protection enables detecting time delay attacks for security, as shown in the below red squares. The system successfully detects time delay attacks. File certification. The malicious program may be injected into the microgrid central controller by an illegal party. It can detect whether the equipment is embedded with the virus program certification by security authentication of all files. Part 2. Grid data. Real-time data collection. The system collects data from downlink devices in real time and analyzes it to show when the microgrid central controller detects abnormal attacks. It will actively cut off the data flow and wait for recovery. The system will automatically resume regular operation after the microgrid central controller is restored to normal. Data transmission security. The edge computing device will transmit various data collected in real time based on encryption and authentication to the master station for backup recovery. The master station will decrypt the received data and display it to each module in real time. The master station will also periodically distribute the key to ensure the validity of encryption. Part 3. Grid business. Microgrid electricity forecast employs different algorithms to predict power generation, facilitating the optimal allocation of individual distributed generation units. Data privacy protection function. High-level users can view all data, while low-level users can only view part of the visible data. The priority of power distribution based on graph computing. The first module calculates the optimal scheme for buying and selling electricity and uploads all real-time transaction information to the blockchain network. The second module is the shortest path of the power distribution. The obtained optimal path of the destination node by selecting different nodes is shown. The third module, User Management Mode, supports multiple users to log in simultaneously for transactions and realizes real-time display of graph nodes. The user publishes the electricity sales information to the public data bar and selects the selling mode. At the same time, the user selects the power sales mode, which are agent mode, demand mode, and response mode. The fourth module is the Cloud and Interaction mode, which is an extension of the User Management mode. The auxiliary developed WeChat applet can obtain all public users' power transaction information and security status. And users can choose power sale and authorization mode for power transactions. After setting the demand for power buying and selling quota, it is synchronized to the cloud to get the optimal program recommendation. False data injection attack. The attacker constructs an attack vector to perform the data injection attack on the system's microgrid devices. The edge side would detect the attack and show the graph of corresponding detection results. Meanwhile, the system detection information is displayed on the text box. Blockchain. All the transaction information data of different nodes under smart grids is normalized to record on the blockchain ledger in a tamper-proof way. Users can query all the corresponding transaction information through identity login. Security policy recommendation. Different scores of security mechanism assess the terminal security level. The security policy recommendation interface shows the evaluation score of the security mechanism and recommendation algorithms. Finally, Docker monitoring. Various applications run on the Docker and new applications can be built on Docker, exploiting the isolation security features of Docker to achieve security isolation of each application. Meanwhile, the Docker security monitoring function has been developed to achieve security monitoring of the system.